Hello everyone, welcome to my channel Middleware Technologies. Today we'll be looking at how we can apply network policies into Kubernetes cluster. Okay, so here in this video I'm going to show you how we can apply network policies into a Kubernetes cluster and see how a pod-to-pod communication behaves with network policies and without network policies. Okay, we'll try to simulate this using two different namespaces with different pods present in those namespace, and how those communication behave when we apply a network policies and when there are no network policies available in that namespaces. Okay, so I'm going to work on Kubernetes cluster. So let me show you my Kubernetes cluster. Okay, so I have a 1.25.2 cluster version installed on my environment with Cilium networking solution installed. Okay, so coming to my documentation again. So what are network policies? Okay, so network policies are basically a kind of restrictions that we apply into a namespace in Kubernetes and try to restrict or regulate the traffic on the OSI layer 3 and 4. So basically it means like we are restricting the traffic or regulating the traffic on HTTP or HTTPS protocols. Okay, so this is how like we can use network policies to regulate or filter the traffic between pod communication in Kubernetes cluster. Okay, in order to use network policies, we need to have a networking solution installed in Kubernetes cluster which supports network policies. Okay, so in my case, like I have as I shown you, like I have Cilium networking solution already installed in this Kubernetes cluster which supports network policies. Okay, so how network policies behave? Okay, so network policies are applied in a specific namespace. They affect a particular set of pods based on labels, and with those pods we are going to apply some egress or ingress rules. Okay, so what does egress rule means? Egress rule means like outbound connections from those specific pods. Okay, so when we are going to apply egress rules for that specific pods which we have selected using the specific labels, the egress rules define the outbound connections like with which these pods can communicate. So basically the egress rules can define can select a particular set of pods in a namespace, or a set of pods or a set of IP blocks or CIDR range with which the pods can communicate. So that defines the egress rules. And coming to ingress rules are like inbound connections which are allowed. Okay, so basically it defines the rules with which the pods can take the incoming traffic from particular set of pods or particular set of pods in a particular namespace or from a specific IP range or CIDR range. So that is how we define the egress or ingress rules. So this is a very basic about what is network policies in Kubernetes cluster. Okay, so let us jump right away into our example wherein we are going to create two namespaces. Okay, so as a first step we are going to create two namespaces. Okay, so let me go into my cluster and let us try to create two namespaces. So we will define our namespace as front end and back end. So basically these are like simulating real-time examples wherein we have front-end applications consisting of set of pods and back-end application or back-end namespaces consisting of a set of pods. Okay, so now like we have created two namespaces. So in that namespace, let us now create two pods and expose them as a service. Okay, so this is my second step wherein we are going to create two pods which are going to use Nginx image, and we are going to expose those pods. Okay, so I'll name, let me see my name, what I have given. So app. Okay, so I have given the app as the name for the front end pod and db as the name for the backend pod. Okay, so let me copy this straight away. So I'm going to create a pod with name app using image nginx in the front end namespace. Okay, so let us try to create it. And similarly, in the backend namespace, we are going to create a pod with name db using the image nginx. Okay, so now if you go into frontend pod and see get pods frontend namespace, you will see the app pod is running, and similarly you can check backend namespace pods. So you see the db is running. So we have two pods ready, but we need to expose them. Okay, so we need to expose our pods in namespace frontend and backend. So we'll do first the frontend, expose pod app on port 80. Okay, so we are doing expose pod app on port 80. Okay, so let me expose this one, and similarly we are going to expose backend pod, that is db, on port 80. Okay, now we have our two pods which are exposed as a service, which we can access using the service DNS name. Okay, so let me clear my screen and let us try to get the details of pods and services in namespace frontend and backend. So let me go into my frontend namespace and get pods comma services. So we see our pod is running and our service is also available to expose that pod on port 80. Okay, similarly if you check for backend, we have pod db is running and the service db is exposing that pod on port 80. Okay, so now we have our two pods ready in the front end and back end namespace. Let me go into my documentation. So now we have the front end pods available, we have front end and back end pods available, and we have exposed them using the cluster IP service. And now like as I have seen, I have shown you, like we have already seen the pods and services which are running in particular namespace. Okay, so now let us go into our next step, that is step 3, that is validating the pod to pod communication without network policies. Okay, so here we are going to see how the pod to pod communication behaves without network policies. So basically we are going to connect from front end to the backend pods and backend pod service, and from the backend we are going to connect to the front end pod service. Okay, so let us do that. So we are going to go into front end pod first in front end namespace. So we are going in the namespace front end, we are going to exec into pod app and do cur backend. So let me see. Okay, so we need to actually use the complete DNS name of the backend. So okay, so basically we need to select the service name, which is db, in the namespace backend, and svc.cluster.local. Okay, now you can see like we are able to get the nginx page from the backend pod. Okay, similarly let us try to get the pod details from front-end app. So we are going to execute it from the backend pod. We are going to access front-end pod service, that is app. Okay, so let us try to access this, and we are able to get the Nginx page. So that means like both the pods in backend and frontend are able to access each other without any restrictions. Okay, so now we have seen like step 3. Let us go into step 4. Step 4 is basically like we are going to apply a default deny policy in both the namespaces. So what does this mean? Basically what we are going to do is in the front end and back end namespace, we are going to apply a policy which will restrict all the ingress and egress connections for all the pods which are running in a particular namespace. Okay, so that basically blocks everything, that pod in a particular namespace is not going to communicate with anything in any other namespaces or in the same namespace also. Okay, so for that we are going to apply this policy. So let us name our policy as frontend deny, or let me take the same name. So we are going to take this YAML definition wherein we are going to apply this network policy in namespace frontend. We are going to select all the pods in that namespace and apply the following ingress or egress rules. So we haven't defined any rules, so basically it means it is going to block everything. Let us try to apply this. Okay, so we have created a default deny network policy in frontend namespace. Okay, so we can just check it, kubectl get. So we are going to run it in particular namespace, that is frontend get netpol, that is network policy. Okay, so we have the frontend default deny network policy available in frontend namespace. So similarly, like we will apply the network policy in the backend namespace also. So let me copy this one. Let us name the file as backend default deny. So here also we are going to apply the same policy but with a different namespace. Okay, so let us apply this one in the backend namespace. So we have created, and let us try to look for our network policy. Backend default deny is available. Now let us go into our next step, that is validating the pod to pod communication with the namespace that we have set up. Okay, so as I said, so if we are going to apply a default deny network policy, all the communication, whether it is inbound or outbound from that particular namespace, is going to be blocked. So that is what we are going to see, like how the pod behaves with network policy in this step. So let us try to go into our front-end pod, which is app, and try to access the db pod service, which is db. So let us try to access this one. So you see it is restricted, like we are not able to get the Nginx page anymore. Similarly, if you go and try to do it from the backend pod, in the namespace backend. So if we are going to go into backend pod and try to access the front end front end pod in front end namespace, we are not able to access the Nginx page anymore. Okay, so this is how the policy applies the rules such that everything is being blocked for the communication between pod to pod. Okay, so now what we are going to do in our next step is we are going to allow egress traffic from front end to back end. So that means like our front end pod, that is app, will be allowed to send egress traffic to a particular namespace. So basically that means it is able to send a traffic to a particular namespace with all the pods which are there in that particular namespace. Okay, so this is what we are going to implement in this step, that is step 6. So we are going to create this front end egress policy. So let me create this file and let us try to copy this YAML definition. So here we are going to apply this network policy in front end namespace. So and we are going to select all the pods which have label run is equal to app. So when we initially created the pod, we used the kubectl run command to create the pod. So every pod that we create using that command will have a label run with the name assigned as the name of the pod. Okay, so we are selecting those pods and we are going to allow egress or apply the egress rule to send the outbound traffic to names to particular namespace which we are going to use select using namespace selector. So we are going to send the outbound connection or traffic to namespace backend which has label kubernetes.io /metadata.name backend. So basically, like when we create a namespace, it automatically gets a particular label which is of this name. Okay, so we are going to send this traffic to all the namespace with this label. Okay, so let us try to apply this policy. Okay, so we have created our policy. So if you want to check, now we will have two policies in front end namespace. Okay, so the first one is the default deny policy and the second one is the egress policy which we are allowing from this particular namespace. Okay, so let us go into our documentation again. So we have created our egress rule and let us go into our next step, which is allowing the ingress traffic from front end to back end. Okay, so in order for a pod in front end namespace to communicate with the backend pod, like we need to have two policies applied. One is the source from let's say our source is front end, so we need to have the source allow the egress traffic to the backend namespace, and also like we need to have the backend namespace allow the ingress traffic from the front end namespace. That means we need to have both the egress rules and the ingress rules applied in both the front end and the backend namespace respectively, so that the pod to pod communication can happen successfully. Okay, so for that purpose, like we are going to now apply the ingress rule ingress policy in our backend namespace. Okay, so let us try to create this definition file. And let me copy my YAML definition. So we are going to apply this policy in the backend namespace. We are going to select all the pods with label run db, and we are going to allow ingress traffic to those pods from pods in a namespace frontend. Okay. So let us apply this policy. So we have applied our policy. So now we can get the details from backend. So we will have two policies now. So one is the backend default deny policy and the backend ingress policy. Okay. So we have now all the policies applied in the namespace frontend and backend, and we are now ready to test how the pod-to-pod communication behaves from frontend to the backend pods. Okay, so let me clear my screen. So we are going to go into our next step, that is validating the pod-to-pod communication from frontend to backend in this step. Okay, so now let us try to take this command which we ran previously without network policies. So we are going to basically call the DB service from the front end pod, that is app, and now you see we are not able to access it still with the fully qualified domain name of the backend service. But let us try to access it using the IP address of the service. So for that, so let us try to fetch the IP address. So we are going to list the services in the backend with O wide so that we get the cluster IP. So this is the cluster IP. Now let us try to access the backend DB service using the IP address. You see, like, we are able to get the Nginx service response, that is 200, so we are able to access this. But if you try to access from the backend to front end, like, we still not be able to access it. So let us try that one. So for that I need to get the, so let me first try with the service name. So we are going to go into our backend pod, which is DB, and try to access the front end service, which is app, in front end namespace .sfc.cluster.local domain. Okay, we are still not able to access it. So let us now try to access it using the app cluster IP. So that let us try to fetch the cluster IP. So the app service cluster IP is this one. Let me copy it and try to access it again with the cluster IP, but we won't be able to access it. Okay, so front end to back end we are able to connect, but only with IP address. But back end to front end we are not able to connect either with the IP address of the service or with the fully qualified domain name of the service. Okay, so why is that? Okay, so basically, like, when we apply the default deny policy, it is going to block all the traffic, as I said. So it is going to block all the traffic on the DNS resolution port, which is on port 53. So it is going to block that traffic also. So it is not able to send a DNS request to resolve the fully qualified domain name to the IP address. Okay, so we need to allow that egress traffic on port 53 so that the DNS resolution can happen successfully. So what we need to do is, in this step 9, we are going to amend the default deny policy in the front end pod, in the front end namespace, such that it is able to send the traffic on the port 53 for DNS resolution. Okay, so for that, first we need to delete that default deny policy which we have created. So we are going to delete it. Okay, so I'm going to use skipctl. I'm not having that alias right now. Okay, so now we have deleted our front-end default deny namespace, front-end default deny policy from front-end namespace. So let us try to retrieve the policies which are available in front-end right now. So we only have the egress rule available. Okay, now let us try to amend our policy, which is front-end default deny. So now what we are going to do is, we are going to apply this egress rule, which basically allows for egress traffic on port 53 on both TCP and UDP. Okay, so this is going to allow the DNS resolution to happen successfully. So let us try to apply this policy again. So now we have the policy applied. So if we try to list the policies now, we have both the policies now ready. Okay, so now let us go into our next step, that is validating the front end to back end pod communication using the fully qualified domain name. Okay, so for that we are going to use the same command which we ran, but we were not able to successfully access the service using the fully qualified domain name. But let us now try. So we are going to access from the front end app the backend DB service, which calls the DB pod. Okay, now you can see we are able to access it successfully. Okay, so this is how we apply the network policies in the Kubernetes cluster. So network policies are namespace specific, and for network policies to be in effect, we need to have a networking solution installed in Kubernetes cluster which supports that network policies. Otherwise, whatever network policies you're going to create and apply, they are not going to have any effect in your namespace or to the pods with which they are going to be applied. Okay, and also in the rules, as I said, we can have egress and ingress rules with which we can identify all the pods with a particular namespace or with a particular label on the pod, and also we can identify all the pods with a specific IP block range, so that we can send the traffic to that specific set of pods. So that can be applied in both egress and ingress rules. So this is what I just wanted to show you in this video, how we can use the network policies in Kubernetes cluster. Thank you all. Thanks for watching this video, and you guys have a great day. Thanks.